In this lecture, we are going to talk about generics. So generics enable types such as classes and interfaces to be parameters when defining classes, interfaces, and methods. Type parameters provide a way for you to reuse the same code with different inputs. The inputs are the types basically. So let's talk about the advantages of generics. First of all, type safety. Type safety means that it is guaranteed that there's going to be just one specific type of object. So as you can see, we can create an array list without specifying that we are going to store strings. In this case, it is not safe as far as types are concerned because we can insert characters, we can insert integers, and so on. If we define that this array list is going to store strings, then it is going to be safe as far as type is concerned because we are not able to insert integers, characters, or any custom objects. It is going to result in a compile time error. So this is why type safety is extremely crucial. Okay, the second important fact is that if we use generics, then typecasting is not required. With generics, we don't need to typecast the given object. If we do not specify the type and we insert a given string, whenever we get that given string, we have to cast that given object. This is called typecasting, and we should avoid typecasting whenever it is possible because it is quite expensive. So this is not the fastest solution possible. If we define that the array list is going to store strings, then Java knows for certain that we are going to add strings and we are going to get strings. So there is no need for typecasting, which is going to result in better performance. So typecasting is not required with generics, okay? And finally, we are able to transform runtime errors to compile time errors. So there is compile time checking with generics. So errors are checked at compile time, so no problem will occur at runtime, which is quite favorable. It is a better programming practice to have compile time checking than runtime checking. So for example, if we use something like this with generics, that we have an array list of strings, we add a given string and we try to add a given integer, then it is going to be resulted in a compile time error. While on the other hand, if we do not use generics, then we are able to add a given integer because we haven't specified the type itself. That's why in that case it is a runtime error. So this is why with the help of generics we are able to transform runtime checking to compile time checking, which is a better programming practice. What about generic methods? We can also write generic methods that can be called with different types of arguments based on the type of arguments passed to generic method. The compiler handles each method. So for example, we have a one-dimensional array of integers, we have a one-dimensional array of characters, then we can create two print array methods. The first method will get a one-dimensional array of integers. It iterates through the integers and print them out. And we have another method with one-dimensional array of characters as the argument, and it is going to do the same. It iterates through the characters and print them out. So this is what we have been talking about, that it is called method overloading. In this case, we have to create several methods. We can do better with the help of generics. So we can define a generic print array method with a generic array, and we can iterate through the generic types and print them out. This smaller than greater than operator is called the diamond operator. This is how we define that this method is going to be generic. The capital T is the generic type parameter and the lowercase t is the instance of generic type T. So with generics, one method is enough and it can be called with different types of arguments. We are going to implement this problem in the coming lectures and it's going to be clear. What's crucial that with the help of generics, we can get rid of method overloading. Okay, let's talk about generic naming conventions. A type parameter can be named anything you want, but the convention is to use single uppercase letters to make it obvious that they aren't real class names. So the following are common letters to use: The capital T is the generic type parameter. This is what we have been talking about in the previous slide. We have the capital E letter for an element, the K for a map key, the V for a map value, N for number, T for generic data type, S and U and V and so forth for multiple generic types. So this is why we use a capital T if we have a one-dimensional array of generic data type, then it is a good programming practice to use capital T. What about generic methods with two types? A generic method can deal with more than one generic type. Where this is the case, all generic types must be added to the method signature. So this is the example for a method with one generic type, and this is the example for a method with two generic types. As you can see, we have to specify that it is going to be a generic method with two generic types, T and S. We will have a one-dimensional array of the first type and a one-dimensional array for the second type. We make a nested for loop and we print out the values accordingly. Again, the less than greater than operator is called the diamond operator. Capital T and capital S are the generic type parameters, and lowercase t and lowercase s are the instance variables of generic type T and S. We can create generic classes. A class that can refer to any type is known as generic class. A generic class declaration looks like a non-generic class declaration, except that the class name is followed by a type parameter section. The type parameter section of a generic class can have one or more type parameters separated by commas. So for example, we have a class name, and we can define that it is going to be a generic class, which means that the class is going to contain generic data type. So that's why we can define a private capital T content. If we do not specify with the help of the diamond operator that this class is going to be a generic class, then we wouldn't be able to use this capital T as a generic data type as an instance variable. So of course we can use several generic data types, capital T, capital S. The T and S type indicates that it can refer to any type like integer, string, a custom object, or whatever we want. The type you specify for the class will be used to store and retrieve the data. When you instantiate the class, you tell the compiler what T and S should be for that particular instance. So this is what we are going to talk about in the coming lectures. In this lecture, we are going to talk about generic methods. So first of all, if we take a look at the array list implementation, we can use an array list without any problem. So I instantiate a new array list, so the java.util.arraylist, and I'm not going to use generics. So in this case, we are able to store any type we want in this array list. So for example, the array list.add, I'm going to insert an integer. Then we are able to insert, for example, a string, Adam. The main problem is that if we want to get that given integer, for example, this is the number, we are able to do so without any problem. But if we do something like this, there's going to be a compile time error because there's a type mismatch, cannot convert from object to int. So as you can see, if we use an array list like this, then Java is going to store objects. So no matter what type we use, Java is going to cast these items into objects. And this is why we have to use typecasting whenever we get that given item. So in this case, we have to specify that it is an integer. If we get the string name, then again we have to make some typecasting, so get with index 1, and it is not that convenient because we have to make castings, and typecasting is quite expensive operation, and on the other hand it is not an efficient programming solution. So this is why we can use generics, where we define that this array list is going to store strings, and if we do something like this, then Java is going to know that we are going to use strings. So whenever we want to get the name, then we can do it without castings. So So if we get the item with index 0, as you can see, there is no need to cast the given value. And this is why using generics is an extremely powerful method, because there is no need for typecasting. Okay, so let's take a look at generic methods. So if we want to create a generic method, public static, we have to define that it's going to be a generic method. Void, for example, print array. Here we can define that it's going to be a one-dimensional array, and we are able to iterate through all the values. So these are the value in the T one-dimensional array, and we just have to print them out. So we print out the value one by one. So if we want to use this generic method, we can do it without any problem. We have a one-dimensional array of strings, for example, the names, Adam, Kevin, Joe, and we call this print array with the names, then it is going to work fine without any problem. If I save and run the application, Adam, Kevin, and Joe. So Java is going to do the following. Whenever we call this method with one-dimensional array of strings, then Java is going to substitute the capital T value with the given type. So it's going to get rid of this. Java will do something like this. And this is how generics is handled under the hood. So of course we want to use it not just for strings, but what if we have a one-dimensional array of numbers? So instead of strings, we are going to use numbers 10, 20, 30, 40. We are able to print out the one-dimensional array of numbers. Yeah, it is true, because we have to use integers, so the object and not the primitive type. If we use something like this, we are able to print the integers with the same method. So as you can see, we are able to avoid method overloading with the help of generics. We don't have to define the same method for characters, strings, doubles, floating point numbers. We just have a single generic method, and this generic method can handle characters, strings, custom objects, whatever type we want. So this is why using generics is extremely powerful. Of course, we can use multiple generic types. So in this case, we have T and V, and here we have two one-dimensional arrays. So we print out the values for the first array, and then we are going to iterate through as far as the second array is concerned, and we print out the values accordingly. So just for demonstration purposes, first array's values and the new line character, and then we use the same here. So this is the second array's values. So if we use a one-dimensional array of integers, and then we have a one-dimensional array of strings, Adam, Kevin, Joe, it's going to be the names, and of course it's going to be an array of strings, then we are able to use the names as well as the numbers. So if I save it and run the application, as you can see, we are able to print out the one-dimensional array of strings, and we are able to print the one-dimensional array of integers with the help of the same method. We can define as many generic type parameters as we want. In this case, we have two generic types, T and V. Okay, so this is how we create generic methods. Thanks for watching. In this lecture, we are going to talk about generic classes. So we are able to create a class, for example, box, and because this class is going to be generic, which means that this class is going to store a generic type, this is why we have to define it like this. So this is how we notify Java that this box is going to contain one or more generic data types. Okay, so this is why we are able to create a private T element. If we do not specify it like this, as you can see, we are not able to use the generic data type. So T cannot be resolved to a type. So this is why we have to make sure that this box class is going to be generic. Okay, here in the constructor, it's going to get a t element, and we have to make sure that this element is equals to the element, and then we can define the public t get element method that's going to return this dot element, and we can define the setter as well, public void set element t element this dot element is equals to the element. Okay, so this is how we can create a generic class that's able to store a generic data type. Of course, we can define as many generic data type as we want. So we are able to use 2 out of the generic data types, as you can see. Of course, in this case, just for demonstration purposes, we just need a simple element. So why is it good? Because now we can create a box and we can define that the box is going to store an integer. So this box is a new box. Of course, we have to define the integer value itself. And then we are able to print out box1.get element, and this is how we can get the value we have inserted. As you can see, in this case, we specified 100, so that's why the value of the generic item is going to be 100. So if we run the application, we get 100. Of course, if we specify string, then we can define, for example, a name, Adam, and if we get the item, Adam is going to be printed out. So in the background, what's going to happen? Java is going to take a look at this argument, and because it is a string, Java will know that, okay, this generic class is going to store strings. So what's going to happen? It's going to do something like this. It's going to replace the t values with string, and this is what's going to be the result. So this is how generics works under the hood. Of course, we have nothing to do with it, so this is why we can define a generic class like this, and Java is going to handle everything. But this is why generics is an extremely powerful feature of Java. Thanks for watching. In the coming lectures, we are going to talk about generic wildcards. So wildcards are represented by the question mark, and they are used to refer to an unknown type. So for example, if we write question mark extends number in the diamond operator, it means that any child class of number, such as integer, float, or double, can be used. We can call the method of the number class through any child class or subclass object. This is called an upper bounded wildcard. So you may pose the question that what is the difference between the question mark and the t parameter we have discussed in the previous lectures, that if we define this t parameter, it means that we can use anything, strings, custom objects, floating point numbers, doubles, integers, whatever we want. As far as upper bounded wildcards are concerned, we can define that, okay, we can use any type, but we have to make sure that given type is going to be the subclass of number. So basically we can narrow the possible classes we can use. So in this case, we can use integers, floats, and doubles, but we are not able to use strings or custom objects. It is called upper bounded wildcards. Wildcards can also be specified with a lower bound, where the unknown type has to be a supertype of the specified type. If we use question mark super integer, it means that any superclass and all its parents of the integer class can be used, such as number or object, because number or objects are the superclass of integer. So this is the main difference between upper bounded wildcards and lower bounded wildcards. So we can define them with the help of the extends keyword or the super keyword. Of course, we can use unbounded wildcards, which means that, for example, this list has an unknown type. It is useful when writing a method that can be implemented using functionality provided in the object class, when the methods don't depend on the type parameter. So in the coming lectures, we are going to talk about upper bounded wildcards, lower bounded wildcards, and unbounded wildcards. Thanks for watching. In this lecture, we are going to talk about upper bounded wildcards. So let's suppose a situation that we have a public void static print method that's going to take a one-dimensional array as t, and we iterate through for t value in the t one-dimensional array, and we print out the value itself. Of course, we have to tell Java that it's going to be a generic method. This is what we have been talking about in a previous lecture. And of course, sorry for that, we have to make sure that the order is matching. So we have to use static right before the void parameter. So this is how we can define a generic method, as we have discussed earlier. So we can use a string names one-dimensional array, something like Adam, Joe, and Kevin. Okay, and we can call this print method with the names. It is going to work fine. This is what we have been talking about in the previous lectures. But this is exactly what we can avoid with the help of upper bounded wildcards. That if we use something like this, that we get a list of question mark and extends number. In this case, this method can handle list of given types that are the child class of the number. So if we use something like this, of course, java.util.list, we can iterate through the number value. For example, numbers, I'm going to use the variable name numbers. We can do it without any problem, and as you can see, in this case we are not able to print the one-dimensional array of strings. Of course, because first of all we have to use something like this, that it is going to be a list, and we have to use a new array list. So new array list, something like this. We can add the given name Adam. We can add Joe. Of course, we have to import java.util.arraylist, and in this case, as you can see, this method is not able to handle list of strings. Why? Because we have defined that the type must extend the number. We can do with doubles. So if we create an array list with doubles, for example 10.5 and 20.5, it is going to work without any problem, and we are able to print out the values. We can use it for integers, so if we use something like this, it is going to work fine as well. So this is why using wildcards can prove to be extremely powerful, because in this case we don't know what's going to be the type, but we are 100% sure that it's going to be a child class of the number. So with the help of this question mark extends number, we can make sure that this list is going to be a list of integers, doubles, or floating point numbers, but this method is not going to handle a list of strings, for example. So this is how we can handle upper bounded wildcards in Java. Thanks for watching. In this lecture, we are going to talk about lower bounded wildcards. So this is what we have been talking about in a theoretical section, that wildcards can also be specified with a lower bound where the unknown type has to be a supertype of the specified type. So if we write question mark super integer, it means that any superclass and all its parents of integer, such as number or object, is going to be fine. So for example, we have a method public static void add and print, and it's going to get the list, and this is where we can specify the wildcard, that it question mark super integer, it's going to be the list. Of course, we have to import the java.util.list interface, and here we can add list, we add 10, then we add 20, and then we print out. So arrays dot toString and list dot toArray. This is how we can print out an array list. Okay, so this is what we are going to do, and because it is the wildcard super integer, we can use it with all the superclasses of integers such as number or object. So for example, if I create a number list1 is equals to a new array list, we add some number, for example 5, and then we add and print the list1, it is going to work fine, as you can see, because the number is a superclass of integer, it is going to work fine. So if we print it out, 5, 10 and 20 is going to be printed out. But we can do the same with integers. So integer, and we add, for example, 1. We save and run it. As you can see, it is working fine because this list can be a type of integer or can be a type of number, or even it can be a type of object. So if we use something like this, it is going to work fine because object is a superclass of integer. So this is called lower bounded wildcards, and it can prove to be very useful. So this is how we can use upper bounded wildcards and lower bounded wildcards. In the next lecture, we are going to talk about unbounded wildcards. Thanks for watching. In this lecture, we are going to talk about unbounded wildcards. So unbounded wildcard type is specified using the wildcard character or the question mark. This is called a list of unknown type. Unbounded wildcard can prove to be useful when writing a method which can be employed using functionality provided in object class, or when the code is using methods in the generic class that don't depend on the type parameter. So for example, we have a public static void print all method that's going to get a list of unbounded type. It's going to be the list. Of course, we have to import the java.util.list interface, and here we can iterate through the object item in the list, and we can print out the items one by one. So if we have a list of integers, list1 is a new array list, we can add items, for example 10, then we can add 20, we can add 30, and then we can call this print all method. So if we call this print all on the list 1, then we just have to save it and run it, and as you can see, it is working fine for integers. It is working fine for doubles as well. So if we use 10.0, 20.0, 30.0, then it is going to work fine as well. We can use it on strings. So if we use something like this, of course we have to specify strings. Adam, Kevin, Joe method without any problem. So as you can see, Adam, Kevin and Joe is going to be printed out. So this is why it can prove to be useful to use unbounded wildcards with the help of the question mark. Thanks for watching.